In this video, I'll share a few lighting and rendering techniques you can use to make your Unity projects look better. Lighting can be a complex topic. I'm going to try and keep this pretty high level for brevity's sake, but if I mention anything in this video that you're interested in learning more about, just reach out to me. I'm also going to show you a lot of techniques here, but I'm going to try and order them so the techniques that give you the biggest bang for your buck are earlier in the video, and some of the more subtle techniques are near the end. That way, if you only have time to watch part of the video, you're still getting some really useful techniques that you can use. At the end of the video, I'll try to provide a list of some good guidelines you can follow on any project to get better results. So feel free to jump ahead. Let's start by looking at our sample scene here. This is a scene I did not create, but I'm going to attempt to make it look better. One of the things I notice first is that the scene looks very flat and cartoon-like. This wall in particular jumps out to me. It's a blue color, but if we select the wall and look at the material that's applied, we can see that it's supposed to be pure white. This particular blue color, this sort of battleship gray, is a color I actually see in a lot of Unity projects, and it's a pretty good indicator that something's wrong with the lighting setup. I'll explain why in a minute. The other thing we can look at is how the scene is actually lit. So there's really only one light in our scene, one true light called this directional light, which is sort of acting as our sun for the scene. So you see it here. Take note that its mode is set to real time. The options for lights are real time, baked, or mixed. Baked lighting provides a highly accurate and realistic result, but baked lighting can only be applied to elements in your scene that are non-moving. For moving elements in the scene or for lights that themselves move, you would choose real-time lighting. The downside there is that because real-time lighting has to calculate shadows and lighting quality once every frame, it has to use a much simpler lighting model, which doesn't look nearly as good as baked lighting. Mixed is an option that is very useful because it lets you sort of use the best of both worlds. It uses baked lighting for the static elements in your scene, but uses real-time lighting for anything that's moving. We'll come back to this light in a second. Now let's actually open our lighting settings panel. I'm going to dock it right here so we can toggle to it easily. So just a couple things I want to point out here is this topic of global illumination. You'll see we have real-time global illumination turned on and baked global illumination turned on. So global illumination is the real-world phenomenon of the fact that light bounces around a room. It doesn't just enter and hit one surface and stop. Global illumination or bounce lighting is really important in achieving a realistic effect because as light bounces around, it takes on the color of the elements in the room and actually redirects the light to light other areas of the room that may not be hit by the direct source of light. So global illumination is a super important thing to getting very good looking lighting. Baked global illumination is going to look best, and baked global illumination only works on objects, like I mentioned before, that are non-moving. Real-time global illumination is a much lower quality sort of simulation of global illumination that you would use when you're forced to use real-time lighting. Generally speaking, you would never want to have both of these enabled at the same time because they're actually going to compete with each other somewhat and double up the amount of lighting. So I'm going to actually disable real-time global illumination because we're going to switch to mostly baked lighting for our scene. Okay, so now let's take a look at that funny blue wall. This wall, even though it appears in an interior scene, is actually reflecting the color of our sky dome. Now it shouldn't be doing that. The reason it's doing that, if we select this wall and look at it in the inspector, we'll see that even though this isn't a moving element, it hasn't been marked as static. So as far as Unity knows, it's expecting this element to be moving. Moving elements, in an attempt to kind of help fake the global illumination, are going to reflect the general color of the sky dome. So that's why this is improperly reflecting our sky dome. If we tick on that static checkbox, we'll get a message that asks if we want to make all the children of that object static as well, because I actually have a composite object here selected. We want to go ahead and make all the children static because none of them are moving. And you'll immediately see a change. We're no longer reflecting the light from outside the room, and we even get some of the lighting from these lights above us highlighted here. So that's a good step in the right direction. So let's do that for the other elements in our scene. So we'll select this device PC element and make it static. And we'll select the environment Office PC Extras and make that static as well. So we're already starting to see some improvement to our scene. But the one thing that looks off to me is that the flooring looks way too bright. And you'll also notice there's a very harsh shadow directly below the desk. The reason for this is these are both lit by our directional light, which is coming from almost straight above us. Now you would think because we're inside that the ceiling should block that light, and it should, but because that light is set to real time, one of the characteristics of real-time lights in Unity appears to be that when we have a surface like this, which is one-sided, it sees the world just like we see the world in the viewport, and the light goes right through that transparent side. There are a couple ways we could address this. We could add a new plane. To block out that light. And that would have the proper effect. Or, as luck would have it, we can select that directional light, and we want to set this to baked anyway to get better lighting in our scene. And it turns out when you set it to baked, it now obeys the geometry better when it comes to two-sided or single-sided surfaces. So now we get the proper occlusion. You should still be able to see a little bit of light coming in here through the windows from that directional light, but all the rest of it is shadowed as it should be. Let's adjust this directional light a little bit. I'm going to rotate it so it comes into the room a little bit more. You'll notice that our updates are somewhat delayed because anytime we change a light setting or move an object, it has to rebake part of the lighting. So this little progress bar in the lower right shows you that progress. There, once our lighting is done, we see it coming into the room a little bit more, and I'm going to increase its intensity. So now you can really see some of that bounce lighting happening. You see that it's bouncing off the carpet and bouncing back up onto the wall. It's even colorizing it a little bit to match the color of the carpet. You can see this even better if we view the baked light map. I'll go ahead and turn off this checkbox for now. So you can see the colorization that's happening here. Okay, so we've adjusted our directional light the way we want it. The other source of lighting in this room actually isn't coming from a real light at all. It's coming from these materials that have been applied to the lighting fixtures. So if we look at that material, it's called ceiling light here. And you'll see that it has an emissive value. So it's set to be white and its intensity is set to 1. Let's go ahead and increase that. Remember, our wall over here should look white, not gray, if our lighting is set properly. So I'm going to increase this to 3. There, we're already looking much, much better. Now you may start to notice a few errors with our lighting setup, particularly on this door here. You see what looks sort of like random pixels. This is a pretty clear indication that there's something wrong with the UV or texture mapping on the 3D mesh itself. And in fact, if you were paying close attention, you'll see that Unity is telling us down at the bottom that there is such a problem. It says mesh doesn't have UVs suitable for light mapping. Consider enabling generate light map UVs in the model importer or create them in your modeling package. It's actually super easy to address this problem. All we have to do is select that mesh. I'm going to select it here, the door mesh. And in our project browser, we see that that mesh is a child of this prefab called Environment Office PC. I'll select that. And in the inspector, you'll see the option that Unity was telling us about, generate light map UVs. So I'm just going to tick that on and hit apply. What it's doing is generating essentially a new layer on that model that textures can be applied to. And that layer is going to be used for this new light map texture that is automatically created for us. After it finishes baking, you'll see the updated shadowing texture be applied. There we go. It fixed the weird pixelation that was occurring. There's a few other objects in our scene that we have to do the same thing for. There's these binders, and there is the desk. Those are probably the two that I found. So we'll select the binders and go through the exact same steps. All right, binders are fixed. Now we'll fix the desk. Okay, now all our UVs have been fixed and our scene is looking pretty good. There's one more thing that I want to fix while we're fixing things. You'll notice that the light is coming in through the windows and hitting the floor, leaving a nice sort of bright spot here. But we'd expect it to be doing the same for these cabinets, and it isn't for some reason. So let's select the cabinets to find out why. So if we look at the material on this cabinet, you'll notice that the shader it's using is one of the legacy shaders. So this was a shader model that was used prior to Unity 5. When Unity 5 adopted something called physical-based rendering, which is a much more realistic kind of shader model. So in order to make this play a little nicer with modern Unity, we just need to change it to the standard shader, which will use that physical-based rendering. So we'll change it to standard. I will also change it to opaque because it's not a transparent kind of material, so it doesn't need to be set as transparent or cut out. So now the lighting will bake one more time to improve some of the shadowing of the objects on the file cabinets. All right, so with those fixes out of the way, there's one more thing I want to add that's going to have a big impact on our scene. You'll notice that where two surfaces come together, like the wall and the floor, for example, or the ceiling and the wall, or even the file cabinet and the desk, it's hard to tell if they're actually touching or not. For example, we can't tell if this file cabinet is right up against the wall or a few inches away from it. And the desk kind of looks like it's floating there. This is because it's missing a phenomenon that's found in the real world where wherever two surfaces come together at an angle, there's some shadowing that occurs. This is called ambient occlusion. And it's an important visual signal to our brains that two things are connected. So we can actually enable ambient occlusion in our scene really easily. We just go to the lighting tab, and because we're baking our lighting, we can just turn on ambient occlusion under our light mapping settings. So let's tick that on. And pay attention in particular to what happens where the wall and the ceiling meet. So there, now you see the natural shadowing that would occur when things come together. I'll toggle between ambient occlusion on and off, and you can see it's pretty dramatic in how much more grounded everything seems. All right, let's move on to the next thing. So now that we've rendered baked shadows and ambient occlusion, I'm noticing something that was kind of a hidden mistake before, and that is the glass pane of the window here. So what we're seeing here is that the window material itself, if we take a look at that, this glass material is set to be mostly transparent. The problem is our wall doesn't really have a cutout there, and so our window is transparent onto just a gray wall that now has shadows on it. So we want to just get rid of the transparency completely on that. So we'll get rid of the transparency completely. And also, since it's glass, I definitely want to crank up the smoothness so we get some reflection in there. So now we have some reflection, but you'll notice another problem, that it's reflecting a questionable view here. What it's actually reflecting is, again, our sky dome. It's not reflecting the interior of our room. That's because we're missing something that's really important to any scene, which is a reflection probe, which sort of captures everything in the scene so that it can be used for reflections. Every scene should have at least one reflection probe, because even if there isn't shiny materials in the scene like glass or metal, every material has some amount of reflectivity, but it's especially important if you've got glass or metal in your scene. So I'm just going to, under lighting, add a reflection probe, and I'm going to position it right in the middle of my room here. There it is. So let's make sure it's somewhat centered. So we've got a reflection probe placed. So now if we look in our door, you'll see that the room is actually reflected in it. It's not a super accurate behaving reflection, but we'll address that in a minute. The other thing that's important with this reflection probe that you may have noticed is it actually contributes to the lighting in our scene. That's because, as I've said before, every material has some amount of reflectivity to it. So the other elements around it are going to affect the way it looks. So if I toggle this probe off and on, with it off, the room has an unnaturally blue tint to it. And again, that's because by default, it's reflecting this blue sky dome. But with it on, it has the much warmer tones that this beige carpet and the wood paneling would provide to the room naturally. Okay, so let's fix this reflection to make it look a little bit better. So you can actually have multiple reflection probes in a room. So I'm going to, with this one selected, I'll just duplicate it. And I'm going to position it right in front of the door. That should be good. And right now you can sort of see this yellow bounding box. That's saying how much, what objects in the room will be affected by that particular probe. We really only need that probe to reflect the things that are over in this corner. So let's go ahead and adjust that a little bit. So there, now it's limited a little bit more to the things in this corner. The other option I'm going to play with for this is normally it uses a sphere-based reflection, which is good for general reflectivity, but it caused that unnatural unmoving reflection that we saw earlier. If we instead switch it to use this box projection, and this really only applies to if you have an interior scene that is more or less rectangular shaped. But what you get is a much better simulation of the reflection. So now if I move around this reflection, you'll see it kind of has the parallax that you would expect a reflection like this to have. Okay, so we're looking really good. One more change. It's a little bit more subtle. that we'll make. Reflections were kind of subtle, but one more change I want to make is actually in how color is interpreted in this room. And this is a change that's new, I believe, in Unity 5 as well. So I'm going to select my build settings, my target platform, which is desktop, and I'm going to open the player settings panel, and then I can close out of this. So in the player settings, you'll see this thing called color space, which defaults to gamma. I mentioned before that Unity now uses physics-based rendering, which gives much more realistic results. But physics-based rendering is really meant to work with the linear color space rather than the gamma color space. So for any desktop projects, for sure, you'll want to choose linear to get much better results. Some mobile devices are still limited to using a gamma color space, so that's why it's still in here. I'm not sure why they default to that, maybe just because it works everywhere. But let's go ahead and change that to linear. It will do some rebaking of our light maps here. There, so now our light maps are rebaked, and to me in particular, the carpet looks much more realistic as one particular thing that stands out. But you also notice it has an effect of the colors tend to get a little richer in this particular scene as well. All right, so another thing we can do, you'll notice that the screen on the PC here is a little dark. So let's examine why that is. So I'm going to select the screen and look at the material that's applied to that. And you'll notice that the screen contents have been applied to the albedo channel or the color channel of this, but it's still treating it as if it were sort of printed on a piece of paper rather than a screen that emits light. So for screens, you usually don't want to use albedo for their contents. So I'm going to delete that image. I'm also going to set the color of our screen to black. To black. And I'm going to increase the smoothness because again, it's made of glass. And so now you can kind of see that it's reflecting the environment around. And to put something on the screen, we want to really put that in the emissive area here, which is the acts as emitting color from that screen. So I'll choose the IBM PC screen texture we have, put it there, and now it looks brighter, and we can even goose that up with the intensity value here. So there, and it still has in the black areas, you can still kind of see the reflection occurring. In our lighting panel, there are a couple more last minute updates I want to make. I usually save these for last because they do increase the render time. So let's do those now. One is to turn on this final gather option. And if you hover over, you kind of get an explanation that this is basically doing more accurate sort of shadowing in tiny areas. So we're going to turn that on and it will regenerate rebake our lighting. It'll take a little longer, but we'll make the other change we want to make while that's happening. So in addition to that, so far we've been doing all our previewing with our light map parameters set to this preset of default medium. If you didn't want to wait for all that render time, you could set it to something like default very low resolution. And you'll notice that the baking time takes significantly less. Actually, not now that I turned on Final Gather, but normally it takes less time. So you might use that when you're iterating and working quickly. But note that the results you see aren't going to be super accurate. So you have to sort of take things you see with a grain of salt. But for once you're pretty happy working at medium resolution, for your final product, you'll want to make sure you set it to the high resolution, and it will do a final build or final bake that is sort of at maximum quality settings. Okay, there's a few more things we can take a look at. Again, we're getting to the much more subtle sort of nitpicky things now, but I'm going to go ahead and switch over to view just our baked light map, and I'm going to turn on the light map resolution grid. So this is showing us the amount of our light map texture, sort of the resolution that it's applying to each surface. And you can tweak this. Generally, you would want to use higher resolution on objects that are going to be closer to the user, and lower resolution on objects that are further away. So looking at this, a few changes I might want to make is this is an awful high resolution for a wall that's very far away from the user. So I might select that wall, and I can override the default scale of that here in the inspector under scale and light map. So I might set that to say a 0.5. Same for the other wall. It looks a little too high resolution. Let's set that to 0.5. Now this desk and computer that the user is going to be very close to, that I would generally want to be a pretty high resolution. So I'll select the desk and set it to maybe a 2.5. Same for the computer and some other parts here. So you get the idea. A good light map resolution setup will usually look like the pixel sizes on every surface are pretty consistent from the viewer's point of view. As a general rule, there are some exceptions, but so now it will bake those with those updated resolutions, and that will help certain things like overly rough or broad shadowing. It will help make that a little more detailed usually. Help get rid of maybe some of these darker spots, like if I increase the resolution of that door jamb, there we go, it increased the resolution there. So now let's go back to our shaded view. And sometimes you'll notice some artifacts like you see over here when you change resolutions, either making resolution too high or too low. What we're really seeing is some compression artifacts because light maps by default are compressed, but we can turn that off, and that often makes those go away. Yeah, so that looks much better. The only trade-off of turning it off is it takes a little longer to load off of disk, but that's usually not that big a deal. So there, I think that's a much higher quality looking scene than what we had before. I'll put up a before and after at the end of this video so you can kind of see the difference. But those are a few techniques that I hope you find useful.